everyone they completed the things in a good way, and I appreciating that. At the same time, the third question want to analyze one more time. You want to know what want to do with that. Okay, the problem is in that particular question we want to construct, or we want to produce one more set of data, one more set we have to create there. So that's a doubt I'm thinking. Okay, so here we are going to that particular question. So you can see here, just observe that. Some of you tried also. Okay, here it is. Question number 3. Okay, this is what the problem, right? Draw a subdivision diagram to represent the following information. So not mention percentage here, just subdivided. So total value we can take. Okay, and I told you that to convert the hint I provided here, that hint is convert the data into single units. Data into the data of a single unit. Okay. Converting that is so easy, right? So factory X, here it is the total quantity sold is 20. Okay, so wages, material cost, miscellaneous cost are for this 20 units, for this 20 units. Okay, if you want to convert that into single unit, just want to do what want to do here? Can anyone say what want to do here? All these digits and all these values that are with the quantity sold, the total quantity sold is here, it is a 20. So what do I want to do here to convert it to single units?
Multiply 420.
I'm asking about here. This is unit price, single unit price. Okay, so 20 into 400 is equal to 800. That's the total value. Here you can see here wages, material, miscellaneous. If you're adding all together, you get only 7,200 only, right? Is that correct or not? Yes or no?
Yes.
Okay, so here we want to convert that into single unit, means 3,200 divided by 20, 2,400 divided by 20, 1,600 divided by 20. So you will get the price in single units. Okay, and you want to mention that. The next question, is it profit or loss? Profit or a loss? Okay, and I have to add. Okay, here it is. You know that the total cost of the product, they sold 1 unit for 400 rupees. Total quantity sold is 20 rupees. So 400 into 20, what will come here? 8,000 will come, right? 8,000. Total money spent to produce that is nearly 7,200 only. So nearly 800 rupees is a profit there. Okay, that also want to calculate. Next here, next unit it is factory Y. Total quantity sold is 30. Selling price for each quantity is 700 rupees. So total income is 700 into 30. That means 21,000. 21,000. Okay. Here the cost of wages is 6,000. Material cost is 6,000, and the miscellaneous it is nearly 9,000. So 6,000 plus 6,000 plus 9,000 is equal to 21,000. There is no profit, no loss. No profit, no loss. Okay. Now you try to do that. So one extra column I want to prepare here. That is profit or loss. Profit or a loss. Okay. One more time. Try that, and by evening submit that. Okay. Let me check it. Any doubt in this? One thing you should do, first convert all these digits into single units. Okay. Single unit. So 3,200 divided by 20, 2,400 divided by 20, 1,600 divided by 20. Coming to the case of factory Y, 6,000 divided by 30, 6,000 divided by 30. Here it is 9,000 divided by 30. Okay. Okay. Don't find it. Just leave that and just calculate these things and draw the diagram and submit by evening. Okay. Is it clear or not? The idea clear or not? Basil, is the idea clear now? Clear or not?
Yes, sir.
Okay, what about Tomlin? Is the idea clear?
Yes, sir.
Okay, just try. Aditya?
Sir, can you explain once again?
Simple. Okay, what I want to do is just to convert the data into single units. Okay, so instead of this 3,400 divided by 20, so it here. Okay, next one 2,400 divided by 20, another digit. So don't go for this 3,200, 2,400, something like that. Just do that calculation for a single unit. Is it clear now? No question in this. Just convert that into single unit price. Okay, single unit price. Otherwise, you are unable to depict that. A long bar diagram required to draw this kind of things there. So just to convert that into single unit price. That's it. And today program is moving forward. Other visual representations are there. Another visual representation methods are there. We are moving forward to that particular area. And you can see here, we already discussed what are the various methods. Geometric diagrams. The geometric diagrams are the next. It is a frequency diagram. Frequency diagram. Can you hear me now? My connection is not stable. Can you hear me?
Yes, sir.
Hello? Yeah, fine. First set is called geometric diagrams. So in geometric diagram, we almost already discussed about bar diagrams. In which bar diagrams we discussed about the simple bar diagram, multiple bar diagram, component bar diagram, or subdivided bar diagram. The fourth one is called with the percentage bar diagram. Next one we discussed about the pie diagram, and most of you completed the task also. Pie diagram also you did well. Okay. Next, we are moving forward with the frequency diagrams. Frequency diagrams. Note down what are the frequency diagrams. Different methods are there. Different varieties are there in frequency diagrams. They are first of all histograms. Histograms. Down. There are histograms, frequency polygons, frequency polygon, frequency curve, Agiles. Okay, histogram, frequency polygon, frequency curve, ogive. Ogive also are of two types. One is less than ogive, other is more than ogive. One more type frequency diagram, histograms, frequency polygons, frequency curves, ogives. Again, ogives can be classified into two, that is less than ogive and more than ogive. The third method is called to be arithmetic line graph or a time series graphs. Arithmetic line graph. Here you can see arithmetic line graph or a time series graphs. Okay. So today we are going to discuss about histograms. How to construct a histogram. What are the specialities of a histogram? Where we can use this histograms. That's what the thing what we want to discuss today. Okay. So moving forward to that particular area. Completed this part. Right? Noted or not? Okay, yes. Fine. Okay, forward to that area. Okay, histogram. Okay, what is a histogram? So you know that a bar diagram, it's a diagram, basically it's a single dimensional, one set of data. In a simple bar diagram, we can represent or can present only one set of data. So a histogram is a two-dimensional diagram, Here, length and width both matters. But in the case of bar diagram, width is not that much important. Okay, clear or not? Can you hear me?
Yes, sir.
Yeah, fine. So it's a two-dimensional diagram here. Both the length and width, length of the diagram and width of the diagram, both are important. It's a set of rectangles with passes as the intervals between class boundaries and with areas proportional to the class frequency. Histogram frequency distribution are of two types. So basically, histograms we can divide two types are there. One is a histogram of equal class intervals and histogram of unequal class intervals. You know that interval. You already learned that learning the chapter, that organization of data, right? Yes or no? Organization of
Yes,
data.
sir.
What do you mean? Class interval, exclusive method, and inclusive method. Exclusive and inclusive method studied today. So here, so histogram is a two-dimensional diagram. Two-dimensional diagram. Both its height of the bar and the width of the bar both matters here. Okay. So otherwise, histogram is basically called as area diagrams too. Area diagrams. Area diagrams. Okay. And you have to all these things here. So what is a histogram? You can see here. A histogram is a area diagram. It can be defined as a set of rectangles with base along with the intervals between class boundaries and with areas proportional to the frequencies in the corresponding classes. I already told here. In such a representation, all the rectangles are adjacent since the base covers the intervals between the class boundaries. There is no gap between the classes. There's no gap between the what we can say that variables here. Okay, so it's a sides of a rectangle are proportional to corresponding frequencies of similar classes and for different classes. The heights proportional to corresponding frequency. Frequency density is always in the y-axis. You can find the frequencies in the y-axis. The other variables in the x-axis. X-axis. In other words, the diagram involving a rectangle whose area is proportional to the frequency of the variable and width is equal to the class interval. Okay, by reading that you will find it is difficulty. Okay, it's a little bit difficult. No worries. We are going to the diagram directly, so you can see here. Okay, here's an example for a. So what the program and a or a simple bar diagram. What is the base thing we can find here? So in the bar diagram we can find there's a gap between the two bars. Gap between two bars. Here, no gaps are there. No gaps are there. So already this graph is an inclusive method. It is so 40 is included. Here you can see 50 is included here, right? So what is the class interval here? Just observe the class interval here. Can anyone say?
10.
Observe the diagram.
20.
Observe properly and say.
10.
Only okay, but 50 and 70 is not written here. Okay, so don't think that is 40 and 60, but the thing is here. Okay, 50 is here. So 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So it is nearly 10 is the interval. 10 is the interval. So 40 is included, 50 also included, 60 included, 70 included, 18 included. Almost all the data or digits are included in this method. Method. Okay, so this is an example for a histogram. So you can see frequencies here. Frequencies are here 5, 10, 15, 20, 25. Okay, so as frequency, you can depict that in the y-axis. Y-axis. OY-axis. Here it is a OX-axis. Okay, so here we are going to find out the differences between histogram and a bar graph. Histogram and a bar graph. Right on. So histogram is a two-dimensional figure. As I told, histogram is a two-dimensional figure. Both the height and width, both are matters. That will create the area. That will create the area. Is that clear? Is that clear or not? Is that clear or not?
Yes, sir.
Can you hear me? Yeah. So both that is both together create it. Okay, both creating the area. That means the height of the diagonal, height of the bar, and the width of the bar. Height of the bar and the width of the bar both are important. Okay. So in the case of a bar graph, especially it is a one-dimensional only. Only the height matters. The width is as per our wish and will. We can choose the width, right or not? Width we can choose as per our convenience, but a height that related with the frequency. It is always with the frequency. There is no connection with the width. Okay, but in the case of histogram, both matters. It is a two-dimensional figure. Both height of the bar and width of the bar both are important. Both together will create an entire area. That's what histogram is called as area diagram. Other name of histogram, area diagram, area diagram. In this picture, if you can see that. Okay, so if you are deleting all these lines, what we can see here, a double staircase function model, a double staircase model you can observe here, double staircase. Okay, it is moving towards the center, moving towards the center. If you're deleting all these lines in between. Okay, so the bar diagram, Subhampal, can you hear? Subhampal, are you there? Subhampal.
Yes, sir.
Shubham? Okay. So listen carefully, listen carefully. It's called to be a double staircase method. Double staircase method. Both from the both sides towards the center. Both sides towards the center. Okay, that's what the formation here. Okay. Whose mic is that? Okay, guys. Coming back. Okay, so double staircase method it is. Okay. And both things are important. I already told you that the height related with the frequency and the width that related with the class intervals. In this example, it's basically we took a inclusive method. Both the upper end and lower end. We took both upper and lower digits. So 40, 50, 60, 70, 80. Okay, up to 140. Both included. So that's double staircase method. Okay, just understand that. Next one, in histogram, we can see that the frequency is shown by the area of each rectangle. Frequency is shown and if you use number, it's easily to understand that. Okay, easily it will represent the area. Easily it will represent the area. So we are taking the accurate height and accurate width. Definitely, it will show the accurate or correct area also. So we will discuss the construction method also, so that you understand it, how to draw it. Okay. Next one, it shows rectangles touching each other. So there is no gap in between. There is no gap between two bars. Okay. In case of bar diagram, see here. Simple bar diagram. See here. Example for a simple bar diagram. There are the gap between the bars. There's no gaps. So that's what the other property. Next property of a histogram. No, there is no gap between. So it shows a rectangle touching each other. Again, here both are touching each other. So away from the disturbance. Someone's mic is unmuted. I'm thinking just mute that. Okay, thank you. Hello, can you hear me now? Hadi Aman, can you hear me? Hadi.
Yes, sir.
Yeah, fine. So this is what the differences between a histogram and bar graph. So here, first of all, it is a two-dimensional figure. The histogram is a two-dimensional figure. Both height and width of the bar is matter. Next one, bar graph, it's one dimension, only the height matters. So the frequency is shown by the area of each rectangle. Okay, so rectangle's area, that basically represent the total, what we can say, frequency. Okay, in the case of bar graph, the height shows the frequency and the width has significance. Okay, only the height matters, but the width don't have that much importance. Third one, it is rectangles touching each other. Case of bar graph, it is touching each other. But in the case of bar graph, it consists of rectangles separated from each other with equal space. Separated from each other with the equal space. Okay, not connected or not touched to. That, what are the differences between histogram and a bar graph? What are the differences between a histogram and a bar graph? Just note down the question, learn it properly class. Okay. Got the question? What is that? What are the differences between a bar graph? Right? Yeah, bar graph and a histogram. What are the differences between a bar graph and histogram? And now take your textbook. You can see here page number 50, page number 50. Subham, do you have a textbook? You have a textbook with you, Subham?
Yes, sir.
Just open that. Take page number 50. Okay, there is a question here. So table number 4.9. Table number 4.9. 4.9. So ask a question from that particular table. Just observe the table carefully. So table number 4.9. Table number 4.9. Everyone, please turn on your cameras. Basil, Tomlin, Karthik. I don't know, it might be a connectivity issue. I can see you. Please check that. Yeah, now it's okay. Fine. Okay, good. Okay, check it here. Page number 5050. Distribution of daily wage earners in a locality of a town. Locality of a town. So two sets of data are there basically. Okay, one is the frequency, other is the class intervals. One is frequency, other is a class intervals. Okay, one want to represent the x-axis, other want to represent in the y-axis. Okay, already we know that what want to come in the x-axis and what want to come in the y-axis. So only to write the frequencies, y-axis are frequencies. So you can see in the figure number 4.5, figure number 4.5, the frequencies are mentioned in the y-axis. Frequencies are mentioned in the y-axis. Frequencies are mentioned in the y-axis, and at the same time, one minute, guys, 1 minute.
Hello.
Hello. Yeah, it's okay now. It's okay now. Fine. Okay. Can you hear me now? Ashish, can you hear me? Ashish,
Yes, sir. Yes.
Yeah, fine. Thank you. Okay. Yes, fine. Okay, come back. Page number 50. You can see here the table. In the table, daily earning. So that is starting from 45, and that is the opening limit, and ending limit is 119. 119. So what is the class interval here, Tomlin George? What is the class interval here?
Sir, 5.
Check properly. What is that? 4 or 5?
4.
4. Okay. You should check that. Okay. So this kind of diagrams, if you are making errors in the calculation, the entire diagram will go wrong. Okay. So just properly. Okay. Now you can see the class intervals in the axis, that's in the x-axis, and frequency in the y-axis. Page number 51, you can see the diagram. You can see that diagram. So you can see here a double staircase method, double staircase method it is. Okay, that's beginning from the both sides towards the middle. So if the construction is easy or not, can you do it or not? So I'm going to give a question for people, sir. Okay, here you can see here. First class it is 45 to 49. 45 to 49. Okay. Next it is 50 to 54. Third one is 55 to 59. So here it is, you can see here 44.5 or 49.5, something like that. Okay. So don't take that into consideration. Instead of that, you write 44, 49. Okay. Like that. So you can see the 45 to 49, only two are there. Only there. So want to keep a point there. Okay. So like a diagram only, like a bar diagram only, easily you can do that. But the thing is, there is no interval between, there is no distance between two bars. Okay. Next, coming to the next interval. Next interval 50 to 54, 50 to 54. There comes nearly 3. So just to point that. Okay. And finally, you should connect all these things. You will get the histogram. Any trouble in that? Any trouble in that construction? Just check here. Anila, are you able to do that?
Yes, sir.
Okay, one more time we will go for the construction here. So that's here. How to make a histogram? How to make a histogram? So now you know that the histogram look like. Okay. So first of all, begin marking the class intervals on x-axis and the frequencies on the y-axis. That's first and foremost rule. First of all, marking the class intervals on x-axis and frequencies on a y-axis. Okay. Anila, is that clear? Anila.
Yes, sir. Yes, sir.
Okay. Next one. The scale for both the axes have to be the same. Scale should be same. If you are saying 1 centimeter for both axes, you should take the 1 centimeter. If it is 2 centimeter, you should take a 2 centimeter. Next one. Class intervals need to be exclusive. Okay. Class intervals need to be exclusive. You can exclude also, no problem. Class intervals you can exclude. There is no importance for class intervals here. Draw rectangles with the bases as class intervals and corresponding frequencies as heights. Okay, base you can see the, the x-axis you can see the class intervals and the corresponding frequency in the y-axis. So you have to point there. A rectangle is built on each class intervals since the class limits are marked on the horizontal axis and the frequencies are indicated in the vertical axis. Already we discussed, we know that. The height of each rectangle is proportional to the current frequency. Each rectangle that is corresponding to the frequency. Okay, should not make a mistake there. Okay, correctly you should plot it. That. So corresponding class frequency if the intervals are equal. Next one, the area of every individual rectangle proportional to the corresponding class frequency if the interval are unequal. Clear or not? So the 7th point, the area of every individual rectangle is proportional to the corresponding class frequency. Okay, class frequency of the if the intervals are unequal. If unequal distribution is there, you can easily find the area by observing the height and width of the bars, heights and the widths of the individual bars. Okay, that's the speciality of a histogram. So although histograms seem similar to graph, there is a slight difference between them. The histogram does not involve any gaps between the two successive bars. That is the most important case here. There is no difference between, okay, or there is no gap between the consecutive bars. No difference or no gap in between. So you can see here in the. Okay. Now we are moving forward with the construction. So in next class, you should be ready with graph paper. Okay, graph paper, pen, pencil, scale, eraser, and everything. Carry. Can you hear me? Hello?
Yes, sir.
I'm thinking I am unable to hear. Yeah, fine. So the next class, be ready with the graph papers. Can you hear me, Abna?
Yes, sir. Yes.
Yeah, graph papers, pencil, scale, eraser, right? All these things should keep with you, keep it ready with you. Okay, and we will explain it one more time. And now just want to understand the properties of histogram. Is that clear or not? The properties are clear or not? Tell me, is
Yes.
that clear or not? Any troubles? Okay, fine. So with these properties, we are going to construct different histograms in the next class. Okay. So want to read the page numbers. I will start the page numbers to learn for today and for the next class. They are page number 50 and page number 51. Page number 50 and 51. Okay, is my voice clear now? It's now clear or not now? Is my voice is clear? It's audible properly. Okay, fine. So here you can, page number 50, the starting from a heading is called to be frequency diagram. Frequency diagram. Subheading histogram. Subheading histogram. And a table is there. You can see here in page number 50, right table number 4.9. And corresponding histogram in the next page, page number 51. Okay, that is 4.5. 4.5. Okay, so 50, you can see other subheading called to be frequency polygon. Frequency polygon. I need to read that for today. Up to here, you read properly and you want to understand the things. Next class, you will prepare. Okay, you will learn to construct histograms. How to construct histograms. So now the properties are clear, I'm thinking, right? The properties of histogram is clear or not? Aishwarya?
Yes, sir.
I can hear Aishwarya. Hanna? Huh? I can hear Hanna. Okay, let me take Amalaj. Aishwarya. Ananya.